Hi, I am Shahreen. Today I am going to explain about air cooling system for engine.
How does it work? Air cooling system direct air circulation over heat dissipation fins or hot parts of the engine to cool them and keep the engine at operating temperatures. Now, this is an engine that use air cooling system. Many motorcycles use an air cooling system for sake of reducing weight and complexity. Engine will produce heat when it operates, and then the heat will transfer to the body and heat dissipation fins of the engine. In this cooling system, the second law of thermodynamics are being used.
The second law of thermodynamics states that heat transfer occurs spontaneously only from higher to lower temperature bodies. The thermodynamic terms that used in heat transfer for this cooling system is convection. Convection is a transfer of heat by the movement of a fluid, liquid or gas, between areas of the different temperature. The equation for convection can be expressed as
Convective heat transfer coefficients H depends on type of media, if it gas or liquid, and flow properties such as velocity, viscosity, and other flow and temperature dependent properties.
then how about water cooling system? Is it different?
Thank you so much, Shahreen, for the good explanation. So now I'm going to explain to you guys about water cooling system.
Water cooling system is actually kind of related to the air cooling system. Let me explain the structure of the system. If you can see here, this is where the combustion happen and it will produce heat, and this is the heat that we need to remove. So, in order to do that, we have to flow a cool water to surround the engine that will absorb the heat from the combustion to the water and to be released at the radiator. Okay, to understand what actually happened here, let's zoom in. So, as we can see here, when the water is flow through the hot surface of the engine, the first law of thermodynamics is being obeyed here, where the energy is balanced. Inside the hot surface of the engine, it contains high amount of energy, and the cool water contains low amount of energy. So this is the initial condition. Then, when these two surfaces are in contact with each other, the zeroth law of thermodynamics is being applied, where it states that when two thermodynamic systems is in contact with each other, they will try to reach equilibrium by transferring the heat to each other until the two systems have the same amount of energy. So, at the end of the process, we can understand that the energy is conserved. Or the easier way to understand, I will show you the equation. So this is actually the basic equation that we learned since high school, which is Q is equal to Q, where the MC theta is equal to MC theta. For theta 1, the temperature change from hot to cold, and for theta 2, the temperature change from cold to hot. So we equate these two equations to show that it's actually balanced.
Next application of thermodynamics is at the thermostat at the cooling system inside the engine. At low temperature, the liquid coolant will only flow inside the engine. And when the temperature of the liquid coolant is high, the wax inside the thermostat will absorb the heat from the liquid coolant according to the zeroth law of thermodynamics to achieve a thermal equilibrium. As the wax absorbs heat, the temperature of the wax will be increased. Thus, thermal expansion will be occur to the wax and causing the wax to expand. As the wax expands, it will push the pin at the thermostat and pull the valve downward. This will cause the valve to be open and let the liquid coolant flow to the radiator to be cool and will flow again to the engine. This process can be reversible, as when the liquid coolant is cold, the wax will be back to the normal volume and the valve will be closed again.